In this video, I'm going to be talking through VS Code's Custom Editor API proposal. Custom editors let extensions provide their own editors using HTML, CSS, and JavaScript that replace VS Code's normal standard text editor here. This enables all sorts of cool use cases. For example, you can imagine having a wysiwyg markdown editor that, as you're typing, actually shows the rendered markdown instead of just showing the markup highlighting itself. You could also have something like an SVG editor or an image editor built directly within VS Code. And there's a lot of cool use cases that are for just previewing things as well. So I could have an object file preview. So previewing 3D things, I could have shader previews. I could have all sorts of cool things that are enabled by this scenario. The Custom Editor API has been in development for a little while, and it's gone through a few different iterations. We're currently hoping to finalize the API, but keep in mind that in this video, I'm talking about custom editors in their current state, as they are in mid-March 2020, so things still may change. Most likely, some of these methods and things will be renamed, but hopefully the fundamentals will remain the same. I haven't really planned out what I'm going to talk about in this video. I don't have a script or anything like that. So my goal is to just kind of explain why custom editors might be interesting to you, how they work, how sort of the API came to be, why it's designed this way, and just hopefully give you some ideas of things you might want to try using custom editors. So let's take a look. So right now I have an extension open here that implements two custom editors. I'm just going to start this extension and let's get going just to show what custom editors are capable of. So this extension registers a custom editor for a text-based file for .abc files here. So any file that ends in .abc, it registers a custom editor, and then for binary files as well. So anything that ends in .cat registers a custom editor for that as well. And all a ABC file is, it is just a text file that's been renamed. All a cat file is a JPEG file that's been renamed to .cat. So let's see what happens when I click on the .abc file. So this is a text editor, but you can see here that it's not VS Code's normal text editor. So if I go to a package.json file, here's VS Code's normal editor. This is a different text editor. And what is actually going on is that this is a custom editor that just implements a text area to let you edit the ABC file. So this is about the simplest possible text-based custom editor you can imagine, just using HTML with a text area to recreate a very simple editor. Now that's on its own not very fancy, but where custom editors are sort of neat are that they actually let you integrate into all of VS Code's normal editor flow. So for example, I can do things like have edit and undo. Those all just work here. So the custom editor is hooking into, let me enable screencast mode so this is a little more obvious. The custom editor is hooking into all the undo and redo events here. And you also saw that when I clicked on the ABC file directly here, it didn't open the text file first, and then I had to open a web view preview or something like that. I just went directly to my custom editor here. So that's one thing that custom editors enable. Another kind of cool thing with text files, so if I split this custom editor, now I have two here. If I add it on one side, they're kind of synced together. But I can also then go and I'm going to say in this one over here, reopen with, and switch to VS Code's standard text editor. And now when I edit now I'm in VS Code's normal editor here, and now when I edit, you'll see that those are also synchronized as well. If I press save over there, both files are saved. You can notice the little dirty indicator goes away. And if I undo over in this text file, it also starts undoing in this custom editor over there. So all of this linking together is actually very simple behind the scenes. It's not very complicated, but for text-based custom editors, you get a lot for free, and you get synchronization with VS Code's normal text files here. It's very easy to implement that. So that is a text-based custom editor. Not the most exciting one. Hopefully for the extension samples, we'll put together something a little bit better, but this one, it lets us test things. Let's take a look at a binary custom editor now. So in this case, I've implemented a binary custom editor. Again, this is just a JPEG file with a new file extension. And this custom editor is also very simple. It's just for testing again, and lets me draw things here. So I can just click down to start drawing and make a bunch of marks. And then the other cool thing is that, of course, when I say Command Z, it actually does start undoing those. If I redo these, it does those as well. And I can even press save, and it will actually save the file to disk. So if we were to look on disk, it has actually saved the data at this point. So that is a binary custom editor. And again, the cool thing about this is that VS Code really doesn't know how to handle binary files before, so that this is the first time that you can really create a custom experience for binary files besides using web views in sort of a hacky way. And then also these custom editors are fully integrated into VS Code's normal events. And it has things like the dirty indicator that are working. If I go over here and say open editors, for example, you can see the dirty indicator there is working, and I can press Command S and it just saves. I didn't have to go implement like a keyboard handler for Command S inside my custom editor here. It is actually using VS Code's save event to implement all of that. Okay, so that's kind of a demonstration of two very simple custom editors. Not the most exciting ones, I know, but they do let us at least look at what custom editors are capable of, and you can probably come up with all sorts of cool things after seeing these. So let's take a look at the API now. So the first thing about a custom editor is that you actually have to let VS Code know that you provide a custom editor at all. And if you've worked with extensions, you know that this often takes the form of a contribution. So in this case, we need to tell VS Code that we provide two custom editors and that these custom editors need to be enabled for specific view types or for specific files. So here in my package.json, I have a contribute section, and this new entry now exists called custom editors, and there are two entries in here. The first one is for the ABC file editor, so we just give it a unique view type here. So this is sort of like a unique class name that is being used internally by VS Code to track, this is the custom editor for that this extension is created for ABC files. We give it a nice display name, so this would be displayed to the user in a few cases. And then finally, we give it this selector, which just consists, in this case, of a file pattern. So it is saying for all .abc files, so anything that starts with, or that ends with .abc, enable this custom editor. The binary editor is the exact same thing. We don't have to specify if it is for text or binary. That all comes later. We are just telling VS Code here is the name of our custom editor, here's the file pattern it's applied for, and here's the display name that we would show to users. This display name, or this view type here, is also used in one other place in the package.json, and that is actually to activate our extension. So we need to say VS Code knows about this custom editor extension, but when you first open a workspace and you haven't opened any files yet, it will not go and activate your extension. The moment I click on that ABC file, it will say, oh, I need a ABC custom editor here, and it will fire this on custom editor activation event with the view type. So you can see that we have these two custom editor activation events for the two view types there. So that is sort of the static contribution part of the custom editor API. And then, again, that's just letting VS Code know that your extension contributes custom editors at all. Now, how that is actually being hooked up to your extension is through a register custom, or through a custom editor provider. And you have to let VS Code, like many other providers, you have to let VS Code know about this provider. So once your extension is activated, you need to call register custom editor provider, and you pass in the view type that you're registering for. So that needs to match what was in the package.json, and then the provider itself. This last option here is more advanced, so I'm not going to talk about it right now. But these providers are overall pretty simple, especially for custom text editors. So you can implement a read-only editor very simply, and you can implement text editors very simply. The most complicated one to implement is a readable and writable binary editor. So let's just kind of talk about these in order of the simplest and kind of most generic is probably the one you want to start with to the most complex. So the simplest one is this custom text editor provider. So what these providers are basically doing behind the scenes is custom editors are implemented using web views, and VS Code needs to say, when I open this document, give me the web view that, for this document. Go fill it in with all the information you need, fill it in with the HTML, CSS, and JavaScript, hook up all the event listeners and things, and make sure that this web view is all set up, and then VS Code handles actually displaying that in the editor. So that is what the provider is doing at a high level. There is also, in terms of these providers, there's the concept of a model. So there is the model for the document, and then there is the views for that document. So just to explain why you need this, in VS Code here, notice I have a VS Code propose open. If I split the editor, so now I have two copies open, I actually have two views of this same file. If I then go and edit somewhere within this file, you'll notice that both of them update. So behind the scenes, there's a single text model that is being used by both of these views, but there are actually two separate editors being rendered. And custom editors have that limitation as well. So there might be a single text model that is being used, but multiple views for that text model. And your extension needs to make sure that it supports that correctly. So what the provider is doing here for text-based files is saying you have a text document. So this is VS Code's normal text document. You're given a web view panel. and then you just have to fill those in. So VS Code, when the user clicks on this .abc file, your extension would activate itself, make sure it registers the custom editor provider with a text editor provider in this case, and make sure it has the right view type. And then VS Code would come along and say, oh, I need to resolve this custom ABC editor. And it would actually go out to your extension and call resolve custom text editor here with the text document for the file that is backing things, and then with this new web view panel that your extension would fill in. Let's go and jump to where this is actually being used in the ABC editor. So first off, this is just registered. The provider has been registered and everything, but let's look at how resolve custom text editor is actually being implemented here. So you can see that the ABC editor, this is the code for it. It is not very long, so 170 lines, and probably like 50 of those are just testing things. So it's actually not a very complicated piece of code at all. You could get this a lot shorter if you wanted to. But this provider has been registered, and again, this is mapping the model, and it's given a view panel here, and it needs to fill in the content for that view panel. So behind the scenes, it is actually using a class to do that. It is creating this ABC editor class. If we go into this class, you can see that it fills out the initial HTML of the web view panel that it's given. It makes sure that that web view panel has things like scripts enabled, and then it also sets up a few event handlers. So as I said, the document that is being passed into resolve text editor is the model. So you need to make sure that when that model is changed, your custom editor also changes. In this case, it would mean that the HTML, we just have a simple text area. We want to make sure that text area reflects the actual content of the document. And then whenever this text area is changed, we need to make sure that we also update the document. So there's just a bunch of logic in here that is actually doing that synchronization. It is not very complex if you actually look through this code, but all this code here is basically the synchronization. So once resolve custom, let's see, go back to resolve. Once resolve custom text editor is finished, we have basically filled in this web view panel with all the HTML and everything we need to set everything up and actually render the custom editor. And we've hooked up all the event listeners to make sure that this editor can work. And at this point, when this function returns, VS Code will come along and actually display the web view panel where it needs to, and everything will be linked together nicely. So that is, again, all you really need to do for a custom text editor. There is the matter of synchronizing the text document with the editor and having the editor synchronized back to the text document. That can be a little bit more complicated depending on exactly what type of text you're working with. But overall, it's really not very complicated. It's a fairly simple model. VS Code handles everything like save. So when you actually press save in the editor, it will go to the underlying text document and save it. You don't need to implement anything for that. Undo and redo are all fired on this text document, and then come to your extension through this onDidChange text document event. So all you have to do is hook up a listener that makes sure you have the right document for that, and then updates your web view. So you get a lot for free with this model. You even get things like backing up and hot exit are all implemented for free when using custom text editors. Again, if you're working with a text-based file format, you should definitely try using the custom text editor because it is the simplest, it gives you a lot for free, and it is quite easy to actually implement. You can really just have to worry about how do you implement a really great editor experience and not worry about all the plumbing of hooking VS Code up to that editor. So that is custom text editors. There is another type of editor, though, called the custom editor, and you can sort of think about this as the more fundamental version of a custom editor. What it is doing is taking the model section of an editor and actually letting you provide that as well. So this means that the model does not have to be for a text file. It can actually be for a binary file, and it leaves all of that up to your extension. So let's take a look at how a custom editor is, or a custom editor provider is implemented here. Again, to register one of these, you just use the same function. It's called register custom editor provider. You can either pass in a text editor provider or a custom editor provider. So let's look at custom editor provider. So in this case, we now have one additional method that you can see. So remember, before VS Code owned the model, now we as the extension own the model. And we need to make sure that we go and create the data model behind the scenes and do whatever we need to do. VS Code does not actually know any information about this model. It is all up to the extension. And the way that this model is stored and expressed is using a custom document object. So this is essentially the counterpart of a text document. but this is actually something that's controlled by your extension. So a custom document has some very basic information that VS Code knows about, such as the resource name, but VS Code does not know like what type of data you store in here. Like you could have all the binary data for the custom document, and VS Code would not know about that at all. So you have the resolve custom document method here and the resolve custom editor method. To understand why there are two methods here, remember the example I showed before where if you split an editor, so if I split the proposed file here, now I have two views to a single model. So in this case, first off, we need to create a custom document when you first open, let's say this was a custom editor. And when I first opened the VS Code proposed d.ts file, we need to create a custom document and create that model that my extension can use to manage this file. And then we'd also need to create a view for it because we want to show that to the user. When I then go and split the editor, however, we already have the model for this resource. We don't need to create another one. We need to just make sure that a second view is created. So we'd actually pass in the same document again and just call resolve custom editor again. This resolve custom editor function is identical in what it's really doing to the resolve custom text editor function we looked at before. It's saying, given a document and a web view panel, make sure you fill in that web view panel to have everything so that it is all set up and can actually be used by the user. The resolve custom document function is a little bit more complex because it's very open-ended in what it's doing. Basically, you are given your extension is given this custom document object, and then it needs to do whatever it needs to do internally to actually implement that custom document object. Let's look at custom document here. This is a very simple view type or a very simple interface. It just has a little bit of simple information on it. So the view type, the URI, so that is the resource that is being opened, an event that tracks when this document is disposed, and then finally this user data field. And this user data field lets you store, or lets your extension store arbitrary data on this document. This is data that VS Code does not have any knowledge about. So you could just store any sort of thing on there. And this custom document object is generic so that you can make sure that this user data field has the right types without having to do a cast or anything like that. So that is basically what a custom document is. And so again, when you open a resource, it would first call resolve custom document, make sure that this document is ready, and then it would call resolve custom editor. If you split the editor or do something like that, it just calls resolve custom editor again. If you then go and you close all of those custom editors, it would say, oh, we don't need this document anymore. Why keep around the model if there are no more editors available for this document at all? So it would actually dispose of the custom document, and then when you open the resource again, it would go and call resolve custom document and go through the same flow, resolve custom editor, and fill everything in there. So that is really all you need to know if you wanted to implement a read-only custom editor for like a binary file. You just need this resolve custom document method and this resolve custom editor method. And you could even not fill in any detail on the resolve custom document. Maybe your custom document just does nothing, and resolve custom editor is where all the main logic is working there if you have read-only files. Let's take a look at a quick look at the AB or the cat editor here to actually show what this is doing. So again, we register our cat draw editor here. So we called register custom editor provider. The provider is actually this class here that we're working in. And then we hook up, so for resolve custom document, we create this model object behind the scenes, and then we set that model as the user data on this document. And then we hook up a bunch of event listeners and just make sure that everything is all set up for that on the model side of things. And then in the custom editor side of things, when we actually need to display an editor for one of these documents, again, we are just filling in the HTML and hooking up all the events that we need for the to actually display that editor to the user. And we get back the same document. You can see that if I'm calling things like document.userdata, and that is actually properly typed to the cat draw model that we were setting up here. So that is the same model that we got back earlier. So again, that is all for a read-only custom editor. But in my example, I was actually showing things like editing, undo, redo, all of those things, save, all working as you would expect. And when you want to implement those, it becomes a little bit more complex because remember, VS Code doesn't have any concept of what the model is. So it can't implement save for you. It has no concept of where we drew in the model in these .cat files, for example. It doesn't know where we drew. It doesn't even know that there is binary data that we are working with. That is all stored on the extension. So VS Code basically needs to expose hooks so that your extension can go and implement save. Let's take a look at those. So on this custom editor provider, we took a look at these first two methods already. And there's one additional property that is this custom editor delegate. And this is where all the editing functionality is being implemented. You can notice that this is an optional property. So if you don't implement this, then VS Code will just assume your editor is read-only, and you won't get undo or save or any of those things working. But if you do choose to implement editing functionality, you need to create one of these custom editor delegates and fill in a bunch of methods. So let's take a look at this delegate. So this delegate has a bunch of methods, but what it basically does is expose, these are all the hooks where VS Code can call out to your extension or where your extension can notify VS Code of various events. So for save, for example, when the user presses save in a document, it would actually, if you have a editable custom editor, VS Code would go and look up the provider for that custom editor. It would see, and it would go and look up the delegate for it, the editing delegate, and then it would call the .save method on that delegate with the custom document. So this is leaving your extension to go implement save however it needs to, and actually write the resource to disk based on its understanding of what this custom document is. Again, it's sort of hard to actually talk about all of these custom document things because it is so abstract. We intentionally designed the custom document and the custom editor API at this level to not make a lot of assumptions, which lets it be used for a lot of different cool things, but it also is so generic sometimes that it's a little bit hard to explain, and it does put a little bit of extra work on the extension side of things, where it would have to actually write the representation of this document to disk here. VS Code itself doesn't help you with that. You need to use various methods such as the VS Code file system API to write whatever it needs to. In this case, it would be the binary data for the image with the drawings on it applied back to the disk. But VS Code doesn't actually specify how you do it. For all it cares, save could just be a no-op. It could just do nothing. But for a real custom editor, you should probably implement save. The same thing for save as. So this is just another hook. When the user says save as in VS Code, it will just call save as on your delegate here, pass in the document, and you can implement it however you want. And then we get to the various editing methods. So VS Code also has hooks for when you undo and redo things. So that is like apply edits, that is the redo case. Undo edits, kind of self-explanatory. You just have a document and then a list of edits that you're getting. Revert and backup is kind of an advanced one, so we'll skip over that for now. But for actually making changes to a file, VS Code will just call these automatically when the user presses Command-Z or Command-Shift-Z to undo and redo. So your delegate can be notified of changes. This edit type is actually left up to your extension, and that also brings us to this onDidEdit property. So this, unlike the other ones, is not actually a method. It is a property that you need to implement on your editing delegate. And this property is, or this event, is the way that your extension notifies VS Code that an edit has occurred inside the editor. So remember with the .cat files, when I pressed down and I drew a line, that would count as an edit. At that point, VS Code has no idea whether or not it should mark the file as dirty, because although the drawing has happened within that web view, so it's all within your HTML that you've set up there. So you need to actually notify VS Code and say, this file has changed. I have made a single edit. If I undo, we would be able to move backwards and undo that edit. VS Code, again, has no knowledge of what that edit is, but you need to tell VS Code that some sort of edit has occurred, and that is where this onDidEdit event comes in. So your delegate implements this, and it needs to fire an event whenever any document that it manages is edited. And if we look at the edit event itself, as you'd expect for this, because it's for multiple documents, you need to tell VS Code, here is the document the edit occurred for, here is the edit itself, and then a label, which is just a human readable string that describes the edit. The edit itself, again, is VS Code does not care what this object is. It could be a giant uint8 array, it could be null, it could be a number, it could be a string, it could be some crazy complex type that you're using in here. All VS Code cares about is that you have fired this edit event to say that a single edit has occurred, and you are then responsible for understanding what to do with these edits in the future. So these are the same edits. Remember here in undo edits and apply edits. Those are the same objects that are going to be passed back to your extension. VS Code does not have any understanding of what those edits are. Your extension needs to be able to understand these edits and undo and redo them. So it's all up to your extension there. But that is basically how you would implement undo and redo and editing for a custom editor through this editing delegate. So again, the editing delegate is the communication channel where VS Code can hook your extension into events like save, undo, and redo, all these kind of core editor features, and also how your extension can hook itself up for getting things like the dirty indicator here. It might be a little bit easier if I actually open the custom editor here and sort of explain what's going on. So when I first press down and make this stroke, the extension would fire that onDidEdit event with the current document here. That is what causes the little dirty indicator here to show up, so VS Code knows this file has been changed. If I then let me make sure screencast mode is on. If I then undo, it calls that undo edits event and says, here's the edit that you gave me. I don't know what this edit is, but you need to undo it. And in this case, the extension can understand that, oh, I should go remove that stroke now. We no longer need it. So that is how undo and redo and all of that is being implemented behind the scenes. Now, if I make a bunch of edits here, and then I press save, VS Code, again, does not actually know what to save to disk. It basically tells your extension, oh, a save event has occurred. So, and there's some edits that have been applied. Your extension needs to make sure that it can take those edits and take the file in its current state, so like the starting state of the file, and write the modified file back to disk. And it's entirely up to your extension how to do that. So you can see that there's a lot of, it's incredibly flexible. Like your extension has a lot of power in representing edits and representing documents and doing all these things. But it also can be really confusing because VS Code doesn't provide a lot of guidance there. So that's all intentional. We tried to make it very open-ended here, but that also makes it a little bit confusing sometimes to know what to do. Again, though, this is all like advanced use case. So if you just have a text file, you don't have to worry about any of this. You get all the editing functionality for free. If you just want a preview type editor, custom editor, so for example, an SVG preview or like an obj file preview or a shader preview, those might be based on binary files perhaps for your previews there. You would actually be able to implement all of that and just not have to worry at all about the editing part of things. So, but if you do need the editing side of things and you need a editor for binary files or for some really complex use case, you do have to get into this editing delegate model where VS Code can hook into your extension and your extension can notify VS Code of what is actually going on. So that is the quick overview of the custom editor API. The actual cat draw binary implementation it's really not that interesting when you actually look at it. It is just going and implementing all of these, like save, for example. In this case, all it does is use VS Code fs write file to write out the contents that it can serialize into a uint array. Save as does the same thing as you'd imagine. So it's actually pretty simple, and this cat draw code is also not very complex. As you can see, it's about 270 lines here, and again, probably a lot of that is extra or just testing code. So not too complex. There are a lot more complications you have to be aware of when you are implementing a custom editor versus a custom text editor, such as making sure that all these edits and everything are being synchronized properly. But they are an advanced use case, and I try to generally steer you away from them if possible. So that is the custom editor API in its current state. There are a few extensions we might be making to it in the future and a few ways it might be revised. But to kind of understand why the API looks this way, it might also be helpful if I just briefly describe some of the things we also thought about while designing this API. So our goal was always to let extensions have the most flexibility possible while also being able to provide, if they want to, have provide an editing experience that feels like it belongs in VS Code. So what we wanted to avoid was having each extension have its own keyboard event listener with a web view that it creates, and it listens for Control Z, and whenever a Control Z happens, it goes and implements undo, and it listens for Control S, and whenever Control S happens, it implements save. all those things. We wanted to avoid that. So our goal from the start was to create a minimal set of hooks that extensions can implement to integrate into VS Code's editing functionality. We give extensions full control over the editor, like how the editor is displayed itself. And our hope is that extensions will be sane and try to provide a editor that actually looks at home in VS Code and not do all sorts of crazy things. But we really wanted to give extensions as much flexibility as possible. So that was kind of the overall goal. And we've designed the custom editor API with this in mind. We went through a number of iterations on this, though, to try to figure out how to guide extensions in the right direction and make sure that the hooks are exposed in the right way, that we aren't making any assumptions that would limit extensions, and that we are generally trying to make sure that extensions do the right thing while also not limiting them in ways that we think that extensions are going to come up with some really cool use cases that we can't even understand yet. And we want to make sure that we don't eliminate those, but also make sure that extensions, as much as possible, have things like hot exit working as you would expect, or save, like when you save a file, it should generally write to disk. That is where things like the custom text editor actually come in. So that, as you saw for the custom text editor, there's very little that your extension actually has to implement. All it has to do is synchronize between the web view that it creates here and the text document. After that, VS Code handles everything. So it handles backup, it handles hot exit, it handles save, it handles undo and redo. So this is sort of our easy getting started model. And again, it's not like this is the basic model. This is the recommended model if you have a text file, because you get all of this for free and VS Code can handle it. The custom editor provider is really only when you do need this other more advanced thing for binary files, which VS Code doesn't have a understanding of. So that is where the custom text editor provider came in. It's letting VS Code provide a lot of this functionality for free and making sure that operations like save, backup, all of those just more or less work. The custom editor provider, though, came in because we recognize there is still this need for these more advanced custom editors as well. Binary custom editors, all of these use cases that are really fancy, we need to give extensions just generic hooks into VS Code, and that is what the whole delegate-based model here is allowing. Again, we have tried to isolate that so that if you just have a preview-based custom editor, you do not need to worry about anything there. So we've really tried to design the API, and we went through a number of iterations trying to find the right balance here, trying to find the right terms, even things just like changing a method name. We did a lot of debate on this to try to say, oh, does resolve imply anything we don't want it to? Would people understand this method differently if we called it something else, for example? So we did a lot of debate here to actually go and implement this all. And then behind the scenes, there's also a lot of work that had to go on as well. So VS Code has always been a text editor, and it knows how to deal with text files. There are a few more advanced editors that it has within it as well that you probably don't even think of as editors, but more like views. For example, like the settings editor here. This is a special editor that VS Code has internally, but we've never had support for letting extensions contribute editors. So even for just basic custom editors, such as that ABC editor, where I clicked on the ABC file and it opened my custom editor here, we needed to wire things up internally so that that custom editor can actually show in the first place and just show automatically. And then also that things like when you press Command S while focused on that custom editor, it goes and updates the correct text document. Then there was also the case of the binary files. So VS Code has no understanding internally of how to work with binary files. It sort of, like I can show what it sort of does here for binary files because it's pretty interesting. So here is my custom editor. If I reopen this with the VS Code standard text editor, it will say, oh, we cannot display this file because it is binary. So it can actually detect that this is a binary file and we shouldn't try to display it. If I say I want to open it anyways, it just goes and it tries to open this file as text. So that's obviously not great, but that is VS Code's pretty much the limit of its understanding of binary files at all. Like it can say, it knows enough to detect that this file is binary, and it knows how to display this file as text if you really wanted to do that for some reason, but it has no model internally of what a binary file is. So we had to do a lot of work to actually make sure that these binary files could all be implemented and that an extension could actually own these files as well, which is a completely new model. there are a lot of assumptions that we had made internally about how things like backup would work. So for implementing hot exit, for example, we need to make sure that the file you're working with is always backed up. Internally, we just assumed that you'd always be working with either text files, so we know how to back those up, or with like read-only binary files. So for like an image editor, for example, or an image preview that VS Code ships, we know that that file is never being edited, so it's very easy to restore it. We can just do whatever we need there, because it's never been edited by the user. Once we introduced custom editors, all those assumptions sort of just fell down. So we had to do a lot of rethinking internally of how we implement all these things, and we're still going through that process of finding ways in which we need to make the code more generic to support these custom documents that now are not only binary files, but ones that VS Code has no knowledge about because they live over in the extension world, and the extension could be storing all sorts of craziness on these custom documents, and that all of this more or less just works. And then also the extensions that are implementing this try to follow VS Code's model and do what a user would expect for these things. So there's a lot of challenges that went into it, but that's one of the reasons it's taken so long. It's just all these assumptions that we had in VS Code that we were always going to be working just with text files. Custom editors came along and pretty much broke all of those. So that's a bit of a digression on the history of custom editors and why it takes time to actually implement them. But we've tried to be very deliberate with this API and very careful. We didn't want to rush it out and try to finalize it too soon. I think custom editors overall, they enable a huge number of really cool use cases. There's probably going to be some use cases that are really terrible as well, where people are putting things within VS Code that really should not be within the editor. Like, not everything needs to live within VS Code. Sometimes it does make sense to have a separate application. But things like having a preview for your assets if you're working on a game, just being able to click on that asset file and have an editor open, and it just displays that information. Maybe you can even, if it's a 3D model, for example, fly about it or do all sorts of cool things, have maybe even a little bit of UI to tweak, like a shader, for example. Those are all really cool use cases. And then there's probably things that we can't even imagine. So I always go back to like wysiwyg editors. So you could have like a wysiwyg markdown editor or a wysiwyg graph editor for like a JSON-based graph file. But there's probably all these use cases that we can't even imagine today that extensions are going to come up with. If custom editors sound like something you're interested in, please give the current API a look. It's all stored on VS Code. I'll link to the issue that is covering custom editors. Try implementing a custom editor. A good starting point would be implementing a custom text editor, again, because that is the simplest one and you get so much for free. If you like that and you have a binary file you want to work with, try implementing a preview for that. And then if you're really feeling adventurous and you have some really cool use case in mind, try implementing a editable binary file using this custom editor provider as well. Share any feedback. Like I said, the API is not finalized yet, so we really are taking additional feedback here. The API might change, but we are hoping to finalize it soon, and I'm really looking forward to see what extension authors end up creating. Thanks.